Unit 1. Periodicity of elements and their properties. Lesson 3. Main groups in the modern periodic table. In this lesson, we will study three groups in the periodic table, which are Group 1 or 1A, which is called alkali metals, Group 2A or Group 2, which is called alkaline earth metals, Group 7A or 17, which is known as halogens. Let's start with Group 1A or alkali metals. They are named alkali metals as their elements react with water, forming alkaline solutions. As you can see, if we have two atoms of sodium plus two molecules of water, they will form two molecules of sodium hydroxide and the hydrogen gas will evolve. Sodium hydroxide is considered alkaline solution, which changes the color of litmus solution into blue. They are located on the left side of the modern periodic table, and they are the first group of S block. This group contains the following elements: Li, lithium, Na, sodium, K, potassium, Rb, rubidium, Cs, cesium, and finally Fr, francium. We won't talk about Fr or francium because it is a radioactive element or unstable element. Properties of alkali metals. They are good conductors of heat and electricity. This is lithium, which is a good conductor of electricity. Sodium also is a good conductor of electricity. Finally, potassium, also a good conductor of electricity. So all elements of group 1A are good conductors of heat and electricity. The second property is most of them have low density, where lithium, sodium, and potassium elements float on water surface, as you can see from the following video. But rubidium and cesium elements sink in water because they have higher density than water. The third property is they are monovalent elements. In other words, their outermost energy level contains only one electron. For example, lithium, its outermost energy level L contains only one electron. Sodium, its outermost energy level M contains one electron. Potassium, its outermost energy level N contains one electron. So elements of group 1A are monovalent because its outermost energy level contains one electron. The fourth property is they tend to lose their valency electrons and change into positive ions. Each carries one positive charge. For example, this is lithium atom. During chemical reaction, it will lose one electron and change into lithium ion. This is sodium atom. During chemical reaction, it will lose one electron and it changes into positive ion, carries one positive charge. This is potassium atom. During chemical reaction, it will lose one electron and it changes into positive ion. The fifth property is they are active elements. So They are kept under the surface of kerosene or paraffin oil. As you can see, if we try to remove the outer layer of rust from lithium, we will see that the layer of rust will be formed again. This is because lithium is active element, so it will react with atmospheric oxygen. The same is done with sodium, but in a faster way. Potassium forms a layer of rust faster than that formed in sodium and lithium. The sixth property is their chemical activity increases as the atomic size increases, where cesium is the most active metal in the periodic table, whereas lithium is the least active metal in alkali group or group 1A. As you can see, the last one is cesium, which is very active. The first one was lithium, which is active but much more less active than cesium. Reaction of alkali metals with water. As we said before, they react with water forming hydroxide or alkaline solution. In case of sodium, sodium reacts with water forming sodium hydroxide and the hydrogen gas evolve. In case of potassium, potassium reacts with water and the potassium hydroxide is formed and hydrogen gas evolves. Give reason 4. Sodium fires are not put off with water. This is because sodium reacts instantly with water and the hydrogen gas evolves, which burns with a pop sound. This balloon contains hydrogen, which is collected from the reaction of sodium with water. And as you saw, it burned with a pop sound. Let's talk about the second group or group 2A, which is called alkaline earth metals. They are located on the left side of the modern periodic table, and they are the second group of S block. This group contains the following elements: Be, beryllium, Mg, magnesium, Ca, calcium, Sr, strontium, Pa, barium, Ra, radium. And we won't talk about Ra or radium because it is radioactive or unstable. General properties of alkaline earth metals. They are good conductors of heat and electricity. For example, if we have a piece of magnesium, as you can see, it is a good conductor of electricity. Also, they are malleable and ductile because they are metals. If we have a piece of calcium, also it is a good conductor of electricity. So all elements of group 2A are good conductors of heat and electricity. All elements of group 2A are good conductors of heat and electricity. The second property is all of them have a higher density than water. So as you can see, all alkaline earth metals sink in water. The third property is they are divalent elements. In other words, their outermost energy level contains 2 electrons. For example, beryllium, its outermost energy level L contains 2 electrons. Magnesium, its outermost energy level M contains 2 electrons. Calcium, Its outermost energy level N contains 2 electrons. So all alkaline earth metals contains 2 electrons in their outermost energy level, so they are divalent. The third property is they tend to lose their valency electrons and change into positive ions. Each carries 2 positive charges. Beryllium atom, during chemical reaction, it will lose 2 electrons and change into beryllium ion, which carries 2 positive charges. Magnesium atom, during chemical reaction, it will lose 2 electrons and change into magnesium ion, which carries 2 positive charges. Calcium atom, during chemical reaction, it loses 2 electrons and it changes into calcium ion, which carries 2 positive charges. The fourth property is the chemical activity of these elements is less than alkaline metals activity. So they are not kept under kerosene or paraffin oil, as you can see. They are active but not very active like alkali metals. Their chemical activity increases as the atomic size increases, where Ba is the most active metal in alkaline earth metals, while Mg is the least active metal. As you can see, we have 4 test tubes. Each test tube contains magnesium, calcium, strontium, barium, and the number of hydrogen bubbles in case of barium is more than that in case of strontium, is more than that in case of calcium, is more than that in case of magnesium. So barium is more active than strontium, is more active than calcium, is more active than magnesium. So magnesium is considered the least active metal in alkaline earth group. Reaction of alkaline earth metals with water. If we try to arrange them in a descending order according to their chemical activity, we will find that barium is more active than strontium, is more active than calcium, is more active than magnesium. Group 7A, halogens. They are located on the right side of the modern periodic table, and they are elements of group 17 which are located in P block. This group contains the following elements: F fluorine, Cl chlorine, Br bromine, I iodine, At astatine. We won't talk about At or astatine because it is a radioactive element and it is unstable. They are called halogens, which means forming salt, because they react with metals, forming salt, as we can see from this reaction. This is the reaction between sodium and chlorine to form sodium chloride. Metal plus non-metal forms salt. This is the same reaction but in another way, heating a piece of sodium, then passing chlorine gas, they will form sodium chloride or table salt. This is the liquid bromine, adding sodium to it or any metal, they will form salt. Group 7A are called halogens because they react with metals, forming salt. Also, the reaction of iodine with any metal such as sodium or potassium. In case of sodium, sodium iodide is formed. In case of potassium, potassium iodide is formed. So group 7A elements are called halogens because they react with metals, forming salt. General properties of halogens. They are monovalent elements. In other way, their outermost energy level contains 7 electrons. This is fluorine. Its outermost energy level L contains 7, and during chemical reaction it will gain 1 electron. So it is a monovalent. This is chlorine. Its outermost energy level M contains 7. So it is a monovalent element. The second property is they tend to gain 1 electron and change into negative ion. Each carries 1 negative charge. This is fluorine atom. During chemical reaction it will gain 1 electron and change into negative fluorine ion. This is chlorine atom. During chemical reaction it will gain 1 electron and change into negative chlorine ion. The third property is halogens exist in the form of diatomic molecules. It means that each molecule of halogen consists of 2 atoms, such as F2, Cl2, Br2, I2. Their physical state is graduated from gas to liquid to solid, where fluorine and chlorine are gases, bromine is liquid, and finally iodine is solid. Let's see this from the following video. As you can see, the first 2 tubes are for fluorine and chlorine. This one is for bromine and the last one for iodine. Iodine solid, bromine liquid, fluorine and chlorine are gases. They are very active elements, therefore they do not exist in nature in elementary state, but they form chemical compounds. For example, you can find fluorine in feldspar stones. Chlorine you can find it in table salt, which is extracted from seawater. Also bromine can be extracted from seawater. The same is done with iodine. So they are very active elements. For this reason, they don't exist in elementary state. They always form a chemical compounds. They react with metals forming salt. For example, the reaction of potassium with bromine, it will form potassium bromide. The reaction of sodium with chlorine, it will form sodium chloride. Each element replaces the element below it in its salt solution. The order of this group is fluorine, chlorine, bromine, iodine. So chlorine can replace bromine because bromine is below chlorine and chlorine is more active than bromine. So chlorine plus potassium bromide, it will give potassium chloride and bromine. Bromine plus potassium iodide. Bromine is more active than iodine, so bromine can replace iodine. So we will get potassium bromide and iodine. The reaction of chlorine with potassium bromide, chlorine can replace bromine because bromine is less active than chlorine. As you can see, this brown color is the color of the formed bromine. Properties of elements and their uses. Sodium. It is used in a liquid state in transferring heat from inside the nuclear reactor to outside because sodium is a metal which is good conductor of heat and electricity. Cobalt 60. This is one of the isotopes of cobalt, cobalt 60, which is radioactive. element. It is used in food preservation because it radiates gamma rays which prevent the reproduction of microbial cells but don't harm humans. Silicon Si. It is used in the manufacture of electronics because it is a semiconductor or a metalloid. Liquefied nitrogen, which is used in the preservation of cornea of eye due to decrease of its boiling point, which reaches -196 degrees Celsius. Know the following: we can get rid of undesirable odors inside the refrigerator using a piece of charcoal, which collects gases on its surface. Thanks for watching. This is the end of lesson 3.